Hey, Algebra 2 class, how's it going? It's Mr. Thomas. I am ready to multiply and divide radicals today. We have a lot of radical groups out there. We have Al-Qaeda, ISIS, we have the KKK, other militia groups. And so that's why I have my tech gear on to protect myself from these radical groups. Oh, actually, never mind. We're actually learning about radical expressions in Algebra 2, not radical political groups. My apologies, I got confused on which class I was teaching. So, forget what I just talked about with the radical groups. Although, stay safe from radical race groups and political groups. But today, we're going to learn about multiplying, dividing radical expressions, which you learned a little bit about radical expressions yesterday. So let's go ahead and get into it. So first, radical expressions multiplying. We can combine radical expressions when the number inside the little radical box is the same. When that happens, we can multiply the two major numbers together. So, for example, look at problem sample A. We have the cube root, okay, so the root is a cube right there, 3. And then the square root, remember there's a little invisible 2 right there. Those roots do not match up. Therefore, the two main numbers cannot be multiplied together. And so we would say, no, this cannot be simplified. But let's look at example B. We have a cube root, so 3, and a cube root, 3. Those roots match up. Therefore, we can multiply -4 and 2 together, and that gives us -8, the cube root of -8. Now, I will tell you, you are going to need a calculator, and I recommend the more powerful calculator, the better you're going to be. And I can click some buttons, and I can type in cube root of -8, and it will give me -2. I know you can't see that, but trust me, that is the answer. Let's move on to another example. So remember, the key is we want to match the roots and then multiply the main numbers. So can we simplify this? We have a root of 4 and a root of 5. Those do not match, therefore we say no, we cannot simplify this. Then we look at example B. We have a root of 5 and a root of 5. Those match up. Therefore, we can multiply -5 and 2. So we could rewrite this as 5, or the fifth root, -5 times 2. And then we would say -10, fifth root. And then we can see if it will simplify any further by grabbing our calculator and typing in the fifth root of, oh, my bad, this is a negative number, so that's going to be positive. I apologize. There we go, I was thinking that didn't look right. Of 10, and let's see if it simplifies. It does not give us a whole number, and so we could just say that this would be our answer. All right, let's move on to simplifying radical expressions. So multiplying, you want to match the radicals or the roots and then multiply them together. So what are we talking about when we talk about simplifying expressions? Well, what we're looking for is we're looking for are there any numbers, or in this case variables, that we can take out of this equation. We can't really use a calculator on this problem because we have the variable of x. And so the way I like to think about this is sort of like a matching game. And so we want to, since we have a cube root, a group of 3, we're looking for a number that can be multiplied 3 times to get us 54. If we can do that, then we can take that out of the radical box. the x's, that's a pretty easy process. So let's just show you how I would work this out. So I've got the cube root. So the first thing I want to look at is I want to look at the 54. And this is where you may need a calculator. And so the first thing I would do is I would just look at, is there a perfect cube for 54? And I see that my answer is 3.7 something. So that's not what I want. So then I look and I say, okay, is there another way that I can break this down? And just off the top of my head, the way I would want to do this is I'm just going to divide 54 by 3, because that's the root. And I'm going to see what I get. I get 18. So I could say, I could rewrite this 54 as 3 times 18, and then we still have our x to the 5th. All right. Then I want to ask myself, okay, does 18 break down any further based on the cube? And so I could do the cube of 18, and I get a decimal. So I need to break it down a little bit further. And so I could just do, okay, what about 18 divided by 3? Well, 18 divided by 3 gives me, and remember I'm bringing this 3 down, so 18 divided by 3 gives me 3 times 6. And I know the 6, when I break that down, is going to give me another 3. And so when I break down the 6 even more, I'm going to say 3 times 3 times 3 times 2, because 6 is the product of 3 times 2. And then I still have my x to the 5th. And so what I'm going to do now is, remember, I have this cube root, right? Is I can either group these together and say, okay, I've got 3 3s, and anything I circle or match 3 of, I could take that out. And so I could rewrite this as 3, and then the 2 is left over, 2 x to the 5th. Now the short way of simplifying the variables is you could just subtract this exponent from 3. And so if I were to do it that way, I could rewrite my answer as 3x and then 2x squared, because 5 minus 3 leaves 2 left over. And so that could be my answer. Another way that you could do this is you could just expand these x's, 1, 2, 3, 4, 5, and then just circle your 3, and you just bring one of those out. So my answer would be 3x radical 2x squared. And I have 2 x's left. All right, it's a little confusing, but I think it's kind of fun. A little bit of puzzle making with matching. So if I were to do this one, I would do it the same way, and I'm going to look to see if 128 has a perfect cube. It does not. And so then I'm just going to say, okay, what is 128 divided by 3? That might give me a more manageable number. Well, it doesn't. It gives me a decimal. And so I say, okay, well, 128 is an even number. So I know that if I divide it by 2, I'll get a whole number. And I get 64. So I'm going to rewrite this as the cube root of 2 times 64 x to the 7th. Now I know that 64 has a perfect square of 8, but I need a cube, and so I can look to see in my calculator, is there a perfect cube of 64? And there is. It is 4. And so we could say, if we were to rewrite this expanding it, we could say 2 times 4 times 4 times 4 And that's all my numbers. And then if I wanted to do all my x's, 3, 4, 5, 6, 7, I can have all those written out like that. And then I'm just going to circle the groups of 3. All right? And so I have a 2 that's left over. So when I rewrite my answer, my 2 is left over. I take a 4 out. I take 2 x's out. And so I'm going to call that x squared. And then I have 1 x left over. That is my answer. Takes a little bit of practice, but I do think it is fun. All right. So let's look at multiplying radicals when we have variables involved. Remember, if something's in a blue box or blue lettering, that's something that you want to write down in your notebook. So I would write this down in your notebook. But when it comes to multiplying radicals, here's what you're going to do. You're going to multiply the numbers together, and you're going to add the degrees of the variables. So on this one, we have the number 72 and 10. We're going to multiply those numbers together, and that's going to give me 720. Then I have x cubed and x. I'm going to add the degrees, so this is like a little invisible 1 right there. So x cubed, or x to the 3rd degree, x to the 1st becomes x to the 4th. And then I have y squared, y cubed, that becomes y to the 5th. Just like that. Now if I wanted to simplify, they wanted me to get it in the simplest form, I'm going to have to do that long process that I just did on the previous slide. And so I'm going to just real quickly look and see, is there a perfect square of 720? There is not. And so that means I'm going to kind of start my process of breaking this number down. And so I see that 720 can also be divided by 2. That gives me 360. And I'm going to go ahead and divide 360 by 2. That gives me 180. Divide that by 2, that gives me 90. I can divide that by 2. That gives me 45. And so I'm going to keep going. 2 times 2 times 2 times 2 times 45. And you would keep on doing this. Now you can obviously, you don't have to do the lowest number. You can find one that has a square. So I'm looking all the way back at this problem right here. I say, okay, 360, I know that 36 times 10 is going to give me 360. And so that's an automatic number that I can square out. And so you could break it down like this and just keep on going, or you can find a larger square and take that out. Since I've already kind of written this, I'm just going to keep on going with the 45. And so on that, I'm going to go ahead and look at 45. That gives me black. 2 times 2 times 2 times 2 times 3 times 15. And then I'm going to break down this 15, and I get 2 times 2 times 2 times 2 times 3 times 3 times 5. Now this is just for the numbers. And so notice I'm going to take out my pairs because there's an invisible 2 right there. So I'm going to take out 2 2s and a 3. And so when I do that, it would be like 2 times 2 times 3 and then I would have the 5 left over. And so I would just multiply these together. 2 times 2 is 4. 4 times 3 is 12. And so I could say 12 radical 5. Now those are just the numbers. We still have to deal with the variables. And so remember there's an invisible 2 right there. So I can just look and say, okay, if I were to expand all these x's, I'd have 4 x's. I'd have 2 pairs of them. And so I could call this x squared. You could also kind of divide y to the 5th. I know there's going to be 2 pairs of that. Y squared, but there's 1 y left over. And so this would be my answer. Now with these particular problems, there are multiple ways to do it. I've tried to show you like a way that I think is maybe the easiest as far as just breaking down step by step. It can be time consuming, but if you can just remember, multiply the numbers to get the radical expression in all, combined, then you can figure out whatever method works best to simplify it. So when it comes to dividing, it's basically the same steps except opposite. Instead of multiplying numbers, you're going to divide numbers, and instead of adding degrees, you're going to subtract them. So looking at this example, we have 18x to the 5th divided by 2x to the 3rd. So I'm just going to divide 18 and 2. That gives me 9. I'm going to subtract x to the 5th and x to the 3rd. It gives me x squared. And then I simplify, and remember this is my little invisible 2. Square root of 9 is 3. And x squared, when you square it, becomes 3x. That would be your answer. I think we have one example of this, and so we'll look at this really quickly. So I'm going to divide the numbers. That's my first step. Divide the numbers. I have 162 and 3, so I'm just going to grab my calculator. And I hope you are seeing that in this particular lesson, you are going to need a calculator. So 162 divided by 3 becomes 54. So I'm going to rewrite this as the cube root of 54, and then y to the 5th, y to the 2nd, I'm going to subtract. I'll do a different color for that. I'm going to subtract, and that's going to give me y to the 3rd. I now want to see if there's a perfect cube for 54, because I'm trying to get it in the simplest form possible, and there's not, but I do remember this problem from earlier, and I know that half of 54 is 27, and so I can do 2 times 27 y to the 3rd, and I know that 3 times 3 is 9, and 9 times 3 is 27, and I would also be able to look this up on my calculator. If I typed in the cube root of 27, it would give me 3, and so when I rewrite this, so that's like 3 times 3 times 3, and so when I rewrite this as my answer, I'm going to take a 3 out. Then, notice I have 3y, so I'm going to take a y out. I'm going to have 3y radical 2. That's my answer. So I feel like getting to this point is going to be easier for you probably. It's easy to divide the numbers. It's easy to add or subtract the degrees under the variables. But simplifying is going to be maybe the most difficult thing. So remember, use those question helps, view examples, pause, and rewind on these videos if you need help. You can also look at the textbook online. You have 8 questions. Good luck, and I will see you in class.